Welcome to Shaken Not Burned, a cocktail of solutions for a sustainable future. I'm Felicia Jackson.
And I am Giulia Bottaro. Each week we interview experts to talk about parts of the sustainable transition and what you and your business need to know to succeed.
Sustainability is complex and constantly evolving, and it can be hard for a business to adapt and remain competitive.
We are here to help you learn all about the changing economy and the ongoing transition.
So join us as we explore the concepts and the tools you need to plot a course for a sustainable future. Welcome to the latest episode of Shaken Not Burned, where we break down the science, the systems and the solutions behind sustainability in order to illustrate the bigger picture of the changing world in which we live. Today we're tackling the global energy transition, what it really means, what it might cost, and why it matters far beyond just power generation and the grid. To help us break it down, we're joined today by Lord Adair Turner, Chair of the Energy Transitions Commission, which is a global coalition of power and industrial companies, investors, NGOs, and experts trying to chart a path to net zero. Lord Turner brings unparalleled experience across finance, industry, and climate policy, from leading the UK's Climate Change Committee to steering the Financial Services Authority through the global financial crisis. In our conversation today, we're actually going to explore what the energy transition really means. So not just scale and cost, but the implications for economies and industry and everyday lives. Globally, it's expected to cost up to $4.5 trillion a year in investment. In the UK alone, estimates range from 108 to 344 billion. But while the price tag may seem high, the long-term payoff in terms of savings, resilience and innovation could be far greater. We're actually also going to look very closely at one of the most complex and critical sectors in the transition, the built environment. Buildings are responsible for a really significant share of global emissions, and transforming how we build, retrofit and power them is essential. So the Energy Transitions Commission recently published a report on achieving zero carbon buildings, and it's actually providing a comprehensive global picture of building sector emissions and the solutions ahead. So Adair, thank you for joining us on the show today. Welcome. What is the energy transition and why does it matter?
What is the energy transition? It's a word used for how we go from our current energy system, where we get somewhere between 75-80% of our energy from the burning of fossil fuels, to one where that percentage goes down dramatically, maybe to 20%, and where even if we are burning fossil fuels, we are offsetting them with carbon capture and storage. And that energy transition from a fossil fuel dominated system to one which is not based on fossil fuels, and we can talk about how you do that, but not based on fossil fuels, is essential if we are to reduce emissions both of carbon dioxide and of methane in order to bring a halt, not to reverse, but to bring a halt to the global warming which is now occurring. Because of all of the factors which are driving CO2 emissions and methane emissions, 80%, 40 gigatons out of 50 gigatons, derive from that energy system. The other 10, very important, essentially derive from things to do with the agricultural system, and not from the use of energy in agriculture, but from the methane emissions produced by cattle and sheep, and from the deforestation driven by agriculture. But 80% of our problem of global warming is how we get energy today and the CO2 and methane emissions that results in. So the energy transition is the transition to a new energy system which no longer produces those emissions.
And I suppose that's one of the things that is difficult for people to get their heads around. The systems work the same way for a very long time, and we're looking to transform it, whether that's through renewable energy or fossil fuels with the use of CCS, or lowering transmission costs by generating energy more closely. But I think this is an area that, has been discussed in quite a lot of depth. What I think people are really interested in is understanding what the energy transition is going to mean in economic terms, in industrial terms, what sort of impact it's going to have on different sectors. And so today, given the publication of your report, I was hoping we could talk about buildings, because we all live in them. Most of us work in them. We go out in them. And we just, I think to a great extent, just take them for granted. So why is it that the building sector is so central to the energy transition?
Of the 40 gigatons I talked about earlier, 35, 36 thereabout is CO2 emissions. And of that 35 or 36 CO2 emissions in total across the whole of the economy, about 12.3 are coming from buildings. They are coming either directly from buildings, because, for instance, we have gas boilers in buildings, or they're coming indirectly from buildings because in our buildings we're using electricity, but that electricity is in part coming from fossil fuels and therefore it's producing emissions there. Or they are coming from what are called embodied emissions, which is when we build a building, we use steel and cement, and there were CO2 emissions in that steel and cement. And then there's a matter of how far you push the definition. If you added the construction of things which are not buildings, which are roads and ports and airports, that would add another 2.3 gigatons and would take it up to over 35%, getting close to 40% of all emissions. So buildings they're not the whole, but they are a very big part of all of the emissions that we produce across the energy-using sectors of the economy.
Now, I'm going to ask a question because I do think the way we define things is incredibly important in the way that we understand things. There's buildings, then there's the built environment. Does the built environment include the infrastructure you were talking about?
The built environment, I think people use to include the infrastructure, the roads, the sewage systems, the utilities. The buildings are the buildings themselves. It's the buildings themselves that tend to produce emissions in operation. I mean, once you've got a road, there's some emissions embodied in that road, but it doesn't require you to have a gas boiler or electricity to run the road. So the embodied emissions in new infrastructure outside buildings are important, but by far the biggest bit is the embodied emissions in actually building buildings, whether they be houses, apartment blocks, warehouses, hotels, and the emissions which come from operating the buildings. And the emissions that come from operating the buildings, they're about 9.7 gigatons of CO2. So they're about a quarter of all our emissions are things that happen day by day, every single day, as a result of how we operate, how we heat, how we cook within the appliances we use within either residential or commercial buildings.
So that's what we're going to concentrate on today. Buildings themselves, not the wider built environment. And the thing that fascinates me about this is that buildings themselves are a very complex thing to decarbonise. But we talk a lot about hard to abate sectors and how we're actually going to decarbonise things like steel and cement. But if they're part of the building's value chain, doesn't that make it even more complicated? So how do we compare in importance the buildings against other hard to abate sectors?
When you talk about constructing buildings, you can either count the emissions as being in the construction of the building, or you can count them as being in the production of steel and cement. And you mustn't double count. Think about these different categories. We have to consider both of those. But I think we have to break it down really into two separate things. One, what will it take to run buildings with less emissions? And what will it take to build buildings with less emissions? We also have to recognize some trade-offs. Sometimes you can build buildings in ways which require more CO2 up front, but less CO2 in operation. I mean, if you make a building with much thicker walls, it will be better insulated, whether in hot countries to keep cool air in or in cold countries to keep hot air in. It will use less energy in operation, but it will have more concrete, more cement, more CO2 emissions when you build it. So sometimes there's a trade-off, but I think the way to make sense is fundamentally to talk about two separate things. One, operating the buildings, two, building the buildings, and then think about the extent to which there's a trade-off.
I think that's an incredibly important point because I do think in a lot of the conversations we have, we don't recognise the importance of acknowledging trade-offs and recognising that sometimes you have to take actions that may not appeal to everybody. There's a lot of diverse opinion about the best way forward, whether it's from fossil fuel companies or climate activists or businesses just trying to survive in a changing world. What do you think are the most effective strategies for cutting emissions in buildings?
Well, the absolute core is electrification, right? So a lot of the way we run buildings at the moment, and actually the majority of the operational emissions, don't come from things that happen in the buildings. They happen because we use electricity, and the electricity is in itself produced from fossil fuels. So part of what we have to do in buildings is to decarbonize the electricity system, and that will automatically decarbonize what happens in buildings. But we have some things in buildings where there's direct use of fossil fuel within the buildings. And the core of that is how we heat space, heat water, and provide heat for cooking. In terms of space heating, which is the biggest of those, that is primarily actually a challenge in the rich developed world. I mean, most of the world does not have, where most of the world people live in the lower latitude, higher temperature countries, do not have big heating needs. But across the whole of Europe, North America, Korea, Russia, Japan, there are significant heating needs. Those are primarily met today by gas boilers, or in some cases still direct use of coal or oil boilers, etc. And the way to get rid of those emissions is to electrify. We have got to take the boilers over time, and it will take us time, out of these buildings, and we've got to replace them with electrical forms of heating. In some cases, that may be simple, what's called resistive heating, just standard old-fashioned electric radiators, which will be familiar to somewhat older members of your audience. I mean, I was brought up initially in a house which was entirely electric till we got the gas in when I was about 10 years old. And that's true of a lot of people of my age. But most people in Britain have been brought up in an environment where the predominant form of residential heating has been a gas boiler. Over time, we should replace that. We should primarily replace it with a technology called heat pumps. Heat pumps is a remarkable technology because what it does is you put in a kilowatt hour of electricity and you get 4 kilowatt hours of heat energy within the home. Now, people say, well, that sounds like magic. How do you do that? It's because you suck 3 kilowatt hours of heat from out of the air outside. The easiest way to understand it is it's an air conditioner pointed round the other way. If you ever stood on the outside of an air conditioner system, you're hit by a blast of hot air. And if you think, turn that run the other way, you'll have hot air going into the building. It will be very cold in the immediate location outside because you're sucking heat out. This is the dominant technology. It will undoubtedly dominate over the long term. It will be a way to very significantly reduce people's residential heating bills, but it requires upfront investment. And I think that's what we have to realize with the challenge of residential heating. There is upfront investment to get a benefit later over time.
Can I ask you a question about residential heating? Because it's not an argument I've had for a while, but I have had it about the potential for using hydrogen in the UK heating system, which to me sounds crazy because I always thought hydrogen molecules and natural gas molecules were different sizes and they might not work in the same piping system, even aside from the risk of catching fire. What's your thoughts on that?
Look, technically, it's possible. You were absolutely right. Hydrogen molecules have a particular challenge is they're very, very small. So they can get through the tiniest cracks. So you need even more perfect seals on your pumps, your tubes, your pipes than you do in a gas network, and they're highly flammable, but so also is gas, methane to use its chemical term. So it is technically possible, but I don't think it's economically feasible. I think if we made that hydrogen from electricity, which is one way to make hydrogen, you end up with very large conversion losses, right? You take 100 kilowatt hours of electricity, you turn it into hydrogen. At that stage, you've only got 75 kilowatt hours of hydrogen. You then pipe it to the home, you put it through a gas boiler, you'll lose another 10% there. You'll only get, 65 or so kilowatt hours of heat for your initial 100 kilowatt hours of electricity. If you take that kilowatt hour of electricity and put it into a heat pump, you'll get 400 kilowatt hours of heat. And I think hydrogen just gets beaten by those fundamentals of the efficiency. Hydrogen has an important role in other sectors of the economy. For instance, it may be the way that in future we make steel, iron more specifically, with using hydrogen as what's called the reduction agent rather than using coking coal, which is carbon. But I really don't think that hydrogen is going to play an appreciable role anywhere in the world as a residential heating source. And it's more because of the economics and the fundamental efficiency rather than the safety, which I think at a cost is a manageable problem.
Thank you for that, because I think, again, one of the points that we're often trying to get across is that there are a lot of technologies and proponents of technologies who see everything, their solution to every problem, instead of thinking there are certain solutions which fit more naturally.
Well, it's interesting to know why a lot of people, first of all, you're absolutely right. As somebody once said, to a man with a hammer, every problem's a nail. And to somebody who's, invested in hydrogen, they want hydrogen to be ours to do everything. And it's also true that to someone with an existing gas network, you want an answer which keeps using that existing gas network by putting a new gas through it, whether it be methane made from waste and bioresources, biomethane, or hydrogen. But for a variety of reasons, and I think, by the way, the biomethane route may exist in some specific environments. I think that's more likely than the hydrogen route. But I think you just fundamentally come back to it. In the heat pump technology, which is not a new technology because it is the same as the air conditioner technology, and air conditioners are being deployed across the whole world, and then they're going to be deployed even more and more as the world gets hotter. Deploying that technology in reverse just has such a fundamental efficiency advantage that I'm absolutely sure that this is going to win out over time.
And I have to say, I love the focus on efficiency because that's important economically, it's important structurally, it's important industrially. It's a really nice way of actually framing the conversation. So I think that explains sort of heatings in residential homes. What's the role of electrification in commercial buildings? What should we be looking at doing?
Well, just if I could add one thing on residential homes later, of course, the key technology to put is in heat pumps, but there's also a big role for insulating houses better. Right. It's a big role, but it's also important not to overstate it. You sometimes hear people say heat pumps don't work unless houses are insulated to a perfect standard. That is simply not true. A heat pump will take 1 kilowatt hour of electricity and put 4 kilowatt hours of heat inside the house, even if it's the worst insulated house you've ever seen.
It's just that if it's not insulated, it'll be lost to the outside world.
But that's true.
So you increase the efficiency through insulation.
But that's your gas boiler doing the same. If you take your heat from a gas boiler and put it into a badly insulated home, you'll lose it.
I see the plumes from my boiler in the mornings.
So we should improve the insulation of homes because it will decrease costs to individuals, but we should not turn it into a fetish. We shouldn't turn it into you can only do something in terms of switching to a heat pump if you've got the perfectly insulated house. It's also true that insulation of houses is important to a thing called demand-side flexibility. It's an important and tricky concept in the electricity system, which is in future, we should think about electricity as being worth more or less at different times of the day, right? On a windy day, on a sunny, windy day in summer, electricity is going to be free. Right? In Australia, for instance, they're talking about electricity being free from 11 in the morning to 4 in the afternoon because they've just got so much solar that they'll give it away. But on a cold evening in winter, from 6 in the evening to 8 at the evening, when everybody comes home from work, switches on a boiler, switches on a kettle, switches on heating, etc., electricity will be expensive. The better insulated your home, the more you can say, okay, I don't need to heat my home at that period because it's keeping the heat I put in earlier in the day. And that's going to enable me to shift my electricity demand to when the electricity price is low. So insulation is incredibly important, not just to reduce the overall amount of electricity we will need when we have electrified heating, but also for us to use that electricity at the times of day when it's in surplus and therefore its costs will be very low. So insulation has a crucial role to play. And in our report, we talk about the different dimensions of insulation, from obvious things like double glazing and heat insulation in the roof through to the more extensive, what are called passive house designs. But what people must not believe is that you have to have every single house insulated to the absolute limit. And that shouldn't be the message, because if that is, some existing houses would just be exorbitantly expensive to insulate, change over to an incredibly high standard.
Again, that's bringing in the point of trade-offs. That makes a lot of sense. And what I really like about it is it's a message that resonates, because if you can load shift off high-priced periods of electricity, you're directly impacting people's cost of living. which is a really powerful and positive thing. And I like that you brought up this issue of demand-side response, because obviously one of the issues, I know I asked about strategies for the decarbonisation of commercial buildings, but I think when we're talking about heating, when we're talking about electrification, we're talking about demand response. There are big implications for power systems and grid infrastructure. How do we deal with that?
Let's take the UK. The UK currently consumes about 300 terawatt hours, which is 300 billion kilowatt hours of electricity per year. And it's actually come down in the last 15 years because appliances have become more efficient. But if we switch from gas boilers to heating our homes with electricity, that will add at least 100 terawatt hours of electricity demand. And that electricity demand will also be quite peaky. It will occur at particular times of year, obviously in the coldest bits of winter, but not in summer. And it will occur at particular times of day. Indeed, broadly speaking, when you look at heating demand, it tends to peak a bit in the morning because people have timers on their heating systems, so they switch on a bit before they get out of bed, but then they maybe switch them off if they're not at home during the day, and then they come on in the evening. And if we simply electrified the residential heating and did nothing else, we would need to build within the electricity system a lot of what's called peak capacity, capacity which can come on at that particular time of day. Now,
so it can meet the high point of demand.
To meet the high point of demand, the peak of demand. And even in a system where we get almost all our electricity from renewables, we can do that because we can store the electricity in batteries, we can store the electricity in hydrogen, in pumped hydro, compressed air, and we can keep a fleet of gas turbines, which are hardly used at all for most of the time, but switch on in these peak periods. But if that's all we do, it will cost us more than it needs to do. So if you can persuade people to make sure your home is adequately insulated, that you can shift your input of heat by a couple of hours away from those peaks, that will reduce the total investment cost we need in the total electricity system. And we will encourage individuals to do that by saying the cost of electricity is lower at 4 o'clock in the afternoon than it is at 7 in the evening, and even lower, between, 12 midnight and 7 in the morning. Now, interestingly, again, it's something that used to exist to a much greater extent than it does today. Your older viewers will remember there used to be a night storage heat in rates for electricity in the middle of the night, which heated up they were sort of big radiators with bricks, which then slowly dissipated their heat during the day. And we tended to move away from that as we moved away from the electrical system. But we will be moving back to a lot of different ways of enabling people, in some cases, to store heat within the home or to retain heat within the home through better insulation. So we need, and there's an entire chapter in our report about this, we need to integrate our thinking about dealing with the heating challenge in high latitude countries with the problem of dealing with how the electricity system will work in future. And by the way, that's also true in the hotter parts of the world where the biggest increase in demand is not going to be heating, it's going to be cooling, and where we need to talk also, and the report also talks as much about cooling in the hot parts of the world as heating in the cold parts of the world.
Well, I think it's one of those things that, the more extreme weather there is, the hot will get hotter, the cold will get colder, and the energy demand for that is going to increase. It's finding a way of balancing it. So what are the sorts of things you think we're going to need to do with the grid system to support this level of electrification? Because obviously there's issues around transmission lines, with the capacity they have to actually transfer or the losses that happen over time, we've got very used to a system that is large generators in one place just sending out power on demand. Is that how the future is going to look, or are we going to have to do things differently?
The transmission and distribution grids, we use transmission to relate to the big things, the big pylons in the countryside running at high voltage, connecting hundreds or thousands of kilometers across the country, and the distribution grids is the wires running down individual streets from local substations. Both those grids will change in future. The transmission grids will change because we decarbonise the electricity supply, and we will have generation in different locations than we have it at the moment. Offshore wind farms in the North Sea rather than, we used to have coal-fired power stations heavily focused, for instance, along the Trent River and other places where they could use natural cooling or where there was coal supply. So there's a natural gas-powered systems or coal-powered systems, which is completely different from renewables. And we are going to have to build, and we are building, transmission links to these new sources of a supply. We need to make sure that there are also market signals encouraging people then to locate them as close as they possibly can to the sources of demand. But on the whole, we will need more long-distance transmission. At the distribution grid level, we will actually need more power to each individual home. Any of your listeners who has installed a heat pump or a charger at home for an electric vehicle, if they had the same experience as me, would have had a discussion with their network provider, their distribution network operator, as it's called, to say, well, do you have enough amps of availability in your house to meet that extra demand? Because we have a lot of people who, if they don't have those, may vary, the maximum amount of electricity they'll ever have, even if they have a, immersion heater for hot water and a kettle on, they'll very rarely go above 7 kilowatts on at the same time. If they have a charger for an electric vehicle in their driveway and they have a heat pump, they'll have an environment where they could have, 20 kilowatts at peak. And so the distribution network operators have to make sure that the power to the individual home can deal with that. And they also have to make sure that the power to the whole street can deal with that. There's what's going into the home, and there's what's going into everything below the level of the substation, which is, hundreds of consumers. And this is where the integration with what happens with the business comes in, because the scale that you need at the distribution level, and therefore the cost, doesn't depend on the average use of electricity. It depends on the peak use of electricity. So if by the mechanisms we can talk about earlier, we can get people to smooth out their electricity demand throughout the day, the distribution system will need less capacity than it would otherwise would, and the charges hitting people's bills from the distribution network operators will come down. So this is why there is this need to think through the integration of the changing nature of the demand for energy from buildings coming from heating, but as I say, in hotter parts of the world from cooling, and the way that impacts the capacity that we need in the distribution system in particular.
So that then actually, to me, connects very nicely with the idea of decarbonisation strategies in commercial buildings, because if you're managing your peak power in the home, a lot of the technologies in commercial buildings are around managing power. So turning off lights, making sure that computers are turned off and that there is not too much energy consumption from data or whatever it might be. The thing that I think is really interesting is we know that 80% of all buildings that exist are still going to be around in 2050. So obviously, there's very little we can do about the built environment. That means that the electrification is the key step towards effective change. But that is expensive. And to date, it has been quite slow. So how do we go about creating an environment where this kind of electrification is going to happen?
Let me just slightly correct something you said in terms of what percentage of buildings that are going to exist already. That will certainly be 80% or even higher in rich developed countries. You go to Africa, India, that's not the case. So there is actually, across the whole of developing world, a huge opportunity to get it right first time, right? And again, you've got to draw one of these distinctions between, in the rich developed world, we have an existing building stock. Sometimes that's quite an old building stock. We have to improve the efficiency of it, but we've got to do a trade-off between the benefits, the operational efficiency of that, and the fact that it's quite costly to retrofit an existing building. When you go to the developing world, if you design buildings right up front, you can dramatically improve their insulation efficiency in ways that do not add much to the cost. And this is a huge opportunity that has to be grasped in the developing world. The second thing to say is that in the developing world, there isn't really an issue about electrification. It's bound to be electric because it's cooling, not heating. right?
Yep.
There's no way to cool except by using electricity. I defy you to burn some gas and cool a building down. Air conditioning is by definition electric. So the challenge there is, one, how do we build buildings efficiently so that they are cheap to run because they don't need as much electricity for the air conditioning as possible? And two, how to manage the buildings in order to minimize unnecessary cooling, minimize unnecessary lighting, and also managing the peaks of demand. And when you go to at least some buildings, you go to an environment where there is a huge opportunity with very sophisticated building control mechanisms. If you take, a large hotel or a large office building, what you typically do is you have what's called an HVAC system, a heating, ventilation, and aircon system. You're doing very complicated circulation of air. You're thinking about, if I use my appliances, for instance, my IT, that will produce surplus heat, which, if you're trying to heat the building, is a thing that you can use. If you're trying to cool the building, is a thing that you've got to get rid of. And so in the area of large commercial buildings, there is huge opportunities from really sophisticated energy management systems. It's also important to realize, however, that when we talk about commercial buildings, we're not just talking about one thing. And they are, they're offices, they're warehouses, they're restaurants, they're hotels, big hotels, and they're little hotels.
They all
and
have
they're
different needs.
schools, and they're hospitals. So they're quite varied in nature. But if they're big units, there is always an opportunity for really quite sophisticated energy management systems to think through all the interconnections between the energy management system. What is also true to say of HVAC systems, as they're called in commercial buildings, or just air conditioners or heat pumps in residential buildings, there is a lot of opportunity to improve the technical efficiency. So let's take air conditioners. Air conditioners typically now work at a what's called a coefficient of performance and efficiency level of about 4, which means that you will, put in a kilowatt hour of electricity, you'll suck 3 or 4 kilowatt hours of heat out of the building, and you'll chuck, 4 kilowatt hours out into the external air. That could go to 8 over time. It's technically possible. So we need to have a big focus on improving the technical efficiency of air conditioners and heat pumps, and of also all the other appliances that we use, whether they be ventilation systems or in the residential space, dishwashers, washing machines, lighting. There is a big opportunity, which we set out on in a report and we quantify, just to have more efficient items of equipment.
I do remember hearing a story many years ago about how one of the early wins in Europe on efficiency increases back when they had the 2020 targets, because there was a small little rule change which said motors in appliances had to be more efficient, and they doubled in efficiency and cut power drain by about 40%. It was incredible.
Very big. And as I say, it's remarkable what's occurred. If you look around our societies, people would say, well, I'm using as much electricity as I was before because I've got even more lights. Most houses have even more lights than before. The number of appliances has gone up. The size of televisions have gone up. But if you actually look at the aggregate figures, we are using less electricity than we were 20 years ago, because all of those items of equipment
more efficient.
Have got more efficient. There is a tendency when we deal with these issues, the energy transition and climate, is to sort of berate ourselves for lack of progress. So sometimes we should say we do achieve progress. The energy efficiency process is occurring, but there's lots of opportunities to push that further.
I think that's a really important message. I was actually having a conversation yesterday with someone who has been in this field for about 4 or 5 years, and they were very focused on the slow movement of climate action and transition. And I was thinking, but I remember 20 years ago, the actual temperature trajectory we were on 25 years ago.
Let's take something, light bulbs. 20 years ago, we had incandescent light bulbs. And if you touch an incandescent light bulb,
it burns.
It was really hot. Now, in the middle of winter, that didn't matter because you like the heat. But throughout the spring and summer, it was just wasted. And in the middle of summer, it was an absolute pain in the neck because it was heating your house when you didn't want it heated. And we have moved away to LED bulbs, which are not just a little bit more efficient, they're 10 times more efficient than an incandescent bulb.
Now, I think one of the things that's interesting here, you talked about the different needs in different environments, say the global north and the global south. We've talked about the fact that we need innovations in the efficiency of the basics, of air conditioning and heat pumps and whatever it might be. Are there particular standards that are around that we should adhere to, or do they differ between different markets? I'm just trying to understand how we get everyone on the same page.
Yeah, the issue of standards is a very complicated one, which we address in our report. Now, the somewhat easier area is appliance efficiency. So broadly speaking, it's relatively straightforward to work out what the energy efficiency of a television, a washing machine, a dishwasher is. And we're all familiar, if you go into a shop and try and buy one of those, there's that color-coded thing from A plus, telling you the energy efficiency, telling you how much it needs. And we're pretty good at having standards that require that the manufacturers test and work out what the energy efficiency is. We label clearly with that. And then what we do is every 5 years or so, we say, well, if it falls below this level, you can't sell it any longer. And that does tend to be a pretty effective mechanism, provided we keeping it rolling, for improving the energy efficiency of those units. What is a trickier area is the insulation efficiency of buildings. Now, you can do it. There are standards on it. We have a whole load of standards in place. Here, they tend to differ country by country, almost inevitably. Building is an essentially local industry. They vary in effectiveness. They vary between some standards which try to define what the builder should do. You have to have insulation of this depth. You have to double glaze. Or others which say you have to have a building which is this level of efficiency. And there are pros and cons of those different approaches, but a balance of those is important. And there is also a major challenge across the world that you get to some countries where you can have those standards, but they're not easy to apply. I mean, let's clear, in a developing, even in the UK, there's an imperfect application of those, particularly in retrofitting homes. Again, I return to the fact that it's relatively straightforward to get it right when we are building a new home, right? And one really bad piece of policy was when, back in about 2012, we got rid of the commitment that all new buildings after 2016 would be built in a close to zero carbon fashion. Because when you're building it up front, it doesn't add much cost to get it right first time. And when you're building it up front, it's relatively easy for regulation to measure
check it
and to work out what's close. When you're retrofitting, it's much more difficult, and we'll never do that perfectly. And of course, there's imperfect, implementation, and that's true even in rich developed societies with well-defined, legal systems and regulation. You can imagine when you go to a developing country, they can have a standard, but are the builders sticking to it? So look, we need to keep working on that whole issue of standard definition and regulation, and developing countries need to develop their ability to certify builders. And again, it differs by sector. You take a developing country like India, there's no reason whatsoever why the big hotels, the big office blocks shouldn't be subject to as tight regulation, as tightly enforced as it is in London. And broadly speaking, that is what they do. But you have to accept in a country like that when you go out to the small towns and villages, don't kid yourself that you've got a mechanism in place today that will enable you to impose completely standardized systems across the world, across the country.
Yeah. Now, you mentioned the importance of designing right in the first place and the problem we have in the UK of having lost our early commitment to net zero buildings. How do we actually... Are there standards for designing buildings that everyone can adhere to, like the LEED standard and all of these different things?
New buildings can be built to absolutely defined standards. And, that's possible, as I say, for bigger buildings in the more urban environments across the world. So that's a really important thing. There are many different standards in place. They differ country by country, but we do talk in the report about how to apply them. And they do drive us down towards more efficient results. When you go to the developing world, there's a whole load of stuff about buildings. There's some extraordinary easy wins, right? If in hot parts of the world you paint your roofs white,
yes, I've
you
heard
will
about
reflect
this.
more sunshine. I mean, if you go to if you go on holiday to a Greek island, you will observe that the buildings are all white. They're white for a particular reason, which is it reflects the sun and keeps the building cool. And there's a huge opportunity in the developing world to just say, I'm trying to get rid of heat, so I want it to reflect back up. There's also a hugely important issue of urban design, of designing whole cities with shade and trees and natural shade. Because one of the challenges we face in the building environment in the parts of the world where the main demand is cooling, not heating, is that global warming is in itself driving both major challenges for human welfare and increases in electricity demand, increases which today are producing more emissions, which are producing more global warming in a completely
vicious circle.
Adverse loop.
Yeah.
So if you look at, for instance, China and India, over the last 2 or 3 summers, they've had soaring demand for air conditioning because they've had heat waves. Sadly, at the moment, and it will take several decades for us to get out of this, a lot of their electricity is produced by burning coal. So more air conditioning demand has meant more burning of coal, has meant more emissions, which is going to drive up air conditioning demand. So it's crucial for those countries, while getting on with, yes, getting air conditioners in place, yes, decarbonising their electricity systems, also, as much as possible, designing cities and designing buildings where you can be cool only with a sort of moderate background of air conditioning, rather than having to sort of blast yourself with really cold air to deal with the heat of the environment.
We're actually going to be having an episode on cities and city planning and how that will actually look. But I think what would be really interesting is, are there any countries or cities that you see as sort of leading the way?
We thought about that, but we're wary of drawing attention to individual cities. I'm not sure I would point to any particular ones as ahead of others. I'm sure there are, but we chose not to in the report. There's certainly, and we do mention it in the report, individual buildings, I can't remember them now, which are real icons of how to build a building with both better levels of insulation, in some cases with less use of building materials into the buildings, which is the other issue we discussed, embedded emissions, and certainly many which we focus on with high levels of building controls, the ones that switch off the light if nobody's in the room, make sure that the cooling gets turned down over the weekend, maybe with 1 or 2 rooms kept cool because, yes, there will be some people in to do office work. Really thinking through how office buildings are used through the week and over the weekend, and making sure that your energy use is tailored precisely against the way that they're used rather than being blanket. So we do highlight those, but I'm not sure I want to name individual cities which have it better than others.
No, that's fair enough. I mean, to be fair, I've been looking at cities and how they've been dealing with climate change for a very long time now, and it tends to go in waves of popularity. There are cities I could name for individual things, which is very different. Yeah, but I'm always open to learning things I don't know. But to our listeners, we are going to add a link to the report in the show notes, so you will be able to look these out for yourselves. That brings me to another question, which may or may not be appropriate, but I'm just thinking about materials. What sort of responsibilities do developers and construction firms and even materials producers actually have to help us in this transition? Do you think it's helpful to extend the conversation to them, or actually keep focused on...
Look, as I said earlier, if you take all the emissions that we're producing, leaving out the agricultural emissions, about 7% of those arise from when we build new buildings. And we call them embedded emissions or embodied carbon emissions. They're embodied in the construction. And then another 2.3 from things which are non-building built environment. And of those emissions into building things, over 90% are fundamentally in steel and concrete, and then in the cement and the concrete. And then there's some plastics, there's some glass, there's some other stuff, but the absolutely core of it is steel and cement. And we know how to decarbonize steel and cement. It will take us time to do it. It will produce an increase in the cost of steel and cement, but we can move away from using carbon as a reduction agent when we make iron to using hydrogen. We can add what's called carbon capture and storage to cement plants. That is possible, and that will be the absolute core of how we in future can build buildings without putting a load of, in producing carbon indirectly. However, there is also a significant opportunity to build buildings with less steel and less concrete.
Yeah.
In part because concrete is itself really quite cheap. It's not a major part of the cost of building a building. Architects and builders don't tend to think, how can I minimize the concrete? They sort of put in a margin for
And they don't really think about it.
caution. They don't really talk about it. And that's why actually a slightly higher price for concrete, if we demanded that it was produced in a zero carbon fashion. Don't worry too much about that, because if it induces people to say, I'm going to use it a bit more efficiently, it'll do it. But there are lots and lots of building techniques about getting the optimal size of buildings right. I mean, I know people love, iconic, very high-rise buildings, but when you do very high-rise buildings, you sometimes reduce the ratio of usable
Space.
floor space to what's called the core of the building, because you've got to put lifts in it, you've got to run the systems all the way up.
Yeah.
So optimizing height of buildings for the ratio of usable space to core space that is required for all the utilities but you can't use. Different ways of using steel frames, different ways of, actually building on site, lots of which we set out. And, which architects are aware of, and creating incentives for that. And then, of course, there is the issue of new building materials, building with a timber, what's called engineered timber, laminated timber. And architects and builders are pushing up the limits of how big buildings you can do from that. I don't want to overstate that case, because even if we could build all the buildings in the world from timber, we wouldn't have enough timber to do that.
No, absolutely.
If you wanted to say, I want to get rid of all the concrete in the world, we should have been planting an area the size of India 50 years ago to give us the timber to do that. So we have to accept that there are some constraints on the timber supply, but there is a useful contribution. And it's, for instance, quite striking that, America's use of concrete is far below Europe's or Japan's or Korea's per head of population, because across a lot of America, residential homes are built out of wood. They always have been. Anybody who goes to New England will be aware of, here's a whole load of wood-built buildings. And that has meant that, you can see it in the aggregate figures. It's just not as concrete intensive an economy as other economies have been. There are significant opportunities. There are also some other opportunities. There's things called hempcrete, which is using hemp mixed with concrete. So we need to explore all of those. They'll certainly make a useful contribution, but at the end of the day, we'll still be using a lot of concrete. So we better work out how to use as little as possible while still making the buildings completely structurally sound and safe. And we got to manufacture, we want to make that concrete and the cement that goes into it in a zero carbon fashion.
I mean, I have to say that sums up almost exactly what we need to be doing in almost every sector, which is do more with less in a more efficient way. So if any of our listeners do want to go into any more depth about these different materials, they'll obviously be able to look at the report. So I think my final question to you is, what are the core things you want people to take away from the research?
Say, one, let's focus on buildings, right? I think people know that we've got to build a zero carbon power system, and they know we've got to debate, is that solar, is it wind, is it nuclear? Everybody knows that's a crucial issue. Everybody knows that there's a crucial issue in road transport. How fast do we go to electric vehicles? But sometimes what happens in buildings, both residential and commercial, is sort of not quite front of center for politicians and policymakers. And it has to be, because it's crucial. That's number one. Two, electrify, electrify, electrify. The only way to decarbonize buildings is to electrify that. And we need a clear plan that we take the gas boilers out of residential homes and that we end up with electrical solutions, which will involve an investment cost to get there. But once we've done it, people are going to be paying lower energy bills to heat their homes than they do at the moment. Three, across the developing world, where there will be a hell of a lot of new buildings built, right? Where most of the buildings in 2060 will be new buildings, let's get it right first time. Design these buildings to a high standard, a high insulation standard, a high control standard. And maybe four is, let's drive technical efficiency improvement. There is lots and lots of opportunities to make washing machines more efficient, dishwashers more efficient, heat pumps more efficient, air conditioners more efficient. We've achieved a lot of that, but there's lots of opportunity left. So let's just keep reinforcing that and driving it on through higher and higher standards and through technical innovation.
Well, I think that's fantastic. I mean, I think you've given a really clear picture of what we need to do and why we need to do it. Adair, thank you so much for joining us today. It's been utterly fascinating. And I hope that we will help in some small way to promote the idea that we need to electrify and we need to think about buildings. Thank you again for your time. And to our listeners, I hope you learned a lot, had some fun, and we'll be back soon.
Thank you very much. It's been nice being with you.